let me start with this. If I give you a function f of x, and I said that's equal to x squared, can you tell me what the derivative of that? 2x, very good. Notice I use capital letter for the function, I use lowercase for the derivative. A lot of times instead of, they just go f of x without the prime, just to indicate that's the derivative, lowercase. A lot of calculus book, when they use a lowercase, that indicates derivative without having to put the slash. If you wanted, you can write that f prime of x like this, the derivative of that. But once you use the lowercase, that means derivative. Now, f of x equals x squared plus 40. What's the derivative of that? It's 2x. If I have f of x equals x squared minus 50, what's the derivative of that? That's 2x. So first, f of x, just for those people, is called the antiderivative of little f of x. So now if I ask you this question, let me write this. What function has a derivative equals to 2x? That's actually what the antiderivative. What function has a derivative equals to 2x? So it could be this, could be this, could be this. Any function that has x squared in it, and it could have plus or minus a number. So the way we ask that question, we go, what is the integral? That's what antiderivative, instead of writing this whole thing, that big S of 2x dx. What function, when you took the derivative with respect to x, you got 2x. And the answer to that is x squared plus any number. That number could be 0, could be positive, could be negative. So that's what the S means. What function has a derivative equals to 2x? So when you see that, that's what it means. Give me that problem backward. And if you remember some of the stuff, we'll be able actually to work it backward. Let's make a table here. Let's refresh your memory. What is the derivative of any constant? 0. Okay. What's the integral of 0 dx? What function has a 0 for a derivative? The constant. We're working backwards. So I'm giving you this, I'm looking for that here. This one, I'm giving you c, looking for the derivative. Here, I'm giving you the derivative, give me the problem. So this should be what? A c. The derivative of any 0 is always a c. The derivative of k times x, k is a constant, is what? K, yes. What is the integral of k dx? What function has a k for a derivative? Isn't that kx? And you always have to add the constant, because it could be 3x plus 4, 3x minus 5, or just plain 3x. The derivative of 3x is 3. I'll go to the next page and write that example. I just don't want to mess this page. What's the derivative of 3x? We said that's 3. What's the derivative of 3x plus 50? Isn't that still 3? What's the derivative of 3x minus 1,000? That's still 3. So what function has a derivative of 3? It's 3x plus a constant c. That's why we always add that constant. That's why here you saw me write plus c. Let me continue with that list. When you are doing derivatives, if you have a constant in front of the function, remember that? What did we do with that constant? We took it outside, right? We said that's k times the derivative f of x, which is, I'm going to use little f of x, because little f means the derivative.
Is that f, like in the first brackets, meant to be a little f2?
No, this is capital. That's the function, that's the derivative. That's capital, that's lower. The capital one is the function, the lowercase the derivative. So here now, if you have a constant, just like before, times f of x dx, and you want to integrate that, you can take that constant outside in the front, just like the way we did here. I can take that k and pull it outside. Same thing we did with that. Again, an example, what does that mean? If I said to you, what's the derivative of 5 e to, well, and let's not use e to, well, let's use e to the x. Well, how about e to the 2x? We said you can take the 5 outside, multiply it by the derivative of e to the 2x. What's the derivative of e to the 2x? That's 2e to the 2x. And the 5 is sitting in the front. So 5 times 2, 10e to the 2x. That's how we did them with the derivative. What's the integral of 5 e to the x, not 2x, e to the x? Because we didn't get to e to 2x yet for integration. Notice 5 is a constant. I can take it outside. The integral of e to the x dx. What function has a derivative e to the x? Almost. Plus c, always a plus c. So it's 5 times e to the x plus c. So you end up with what? 5 e to the x. And what is 5 times a constant? Isn't it still a constant? So you just put c. You don't put 5c, because 5c is still a constant. Want to make it a bigger c? Go ahead. But it's still a constant. So what the rule says, if you have a number, you can pull that number outside the integral and still integrate. With derivatives, if you have addition, subtraction, what did we do? Did we find the derivative of the first? And if it's addition, we add it, subtraction, we subtract. The derivative of the second. Well, we do the same thing here. If you were to integrate f of x plus g sub x dx, you can break it down, the integral of f of x dx plus the integral of g sub x dx. I'm just talking about the properties of integrations. Let me give you one we know the answer to. What is the integral of e to the x plus 3x dx? I'm using this because I have both answers up in front of me. I can break this one down to what? The integral of e to the x dx plus the integral of 3x dx. What is the integral of e to the x? What function has e to the x for a derivative? E to the x plus c. Very good. And what function has... I meant 3 here, not 3x. I meant 3 here, sorry. What function has a 3 for it? I'm trying to use that function there because we know the answer to. What function has a 3 for a derivative? 3x plus c, right? What's a constant plus a constant? Still a constant. So you don't have to write c and c again. You just make it 1c. The only reason I know the integral of 3 dx is 3x plus c because I did it right there. But what happened if I just said to you, what's the integral of x to the 5th dx? Wouldn't know that. So let's find the rule that will integrate. Oh, you're still writing? Go ahead. Let me add to that list. Remember the definition of the derivative of x to the n? What do? You move the power to the front and you subtracted 1 from the power. Subtracted, not added. You subtracted 1 from the power. What is the integral of x to the n? So you have to think backward. I subtracted 1 from the power, so to get that function back, what do you need to do? Add 1 to the power. Here I multiplied by n. Here I got to do what? Divide by n plus 1. So you add 1 to the power and you divide by the new power. And you're always going to add what? C. There's only one place where this doesn't work. Where? N cannot be -1. Why? What's -1 plus 1? 0. You can't divide by 0. And this is really the biggest one right now, is right there. The integral of x to the n dx, you add 1 to the power, divide by the new power. So here we go. Let me try some examples. What is the integral of x to the 4th dx? What do? Add 1 to the power and divide by the new power. When you add 1 to the power, what are you going to have? X to the 5 over what? 5, and don't forget to add what? C. I bet you if I take the derivative of this, let me go to the side, take the derivative of that, do I get x to the 4th? Because that problem, it's 1/5, if you look at it, x to the 5th plus c. Let me take the derivative of that. What's 1/5 times 5? 1. X to what power? 4 plus, what's the derivative of any constant? 0. So what's your answer? X to the 4th. We're saying what function has x to the 4th for a derivative? It's right there. We just proved it right here. What is the integral of x to the 7 dx? Add 1 to the power, divide by the new power. What is the integral 3x to the 5 dx? I just said if you have a number, what can you do with the number? Move it to the front. And what's the answer to x to the 5th? Try again. X to the 6 over 6. And you always add a c. Not 3 times c. You don't need 3 times c, still c. If you simplify that, that would be what? X to the 6 divided by 2 plus c. What's the integral of x to the 4th dx? I didn't mean to do that. Wait, don't write that. X to the 4th minus 3x squared plus 7 dx. Here we go. This is x to the 4th dx. I can break it down. Minus, I can take the 3 outside. X squared dx plus 7 dx. I can break it down to individual pieces. Soon enough, you will need to do that. What is the integral of x to the 4th? X to the 5th over 5. What's the integral of x squared?
X cubed over 3.
Yep. Plus, what's the integral of any constant? Not 0.
X.
It will be 7 times x, the constant times x.
Yeah.
And don't forget to add the c.
So that's minus 3 times the derivative, not the integral of dx minus 3.
What are you looking at?
The second line up from the bottom, where it's x to the 4th dx minus 3. You don't take, I'm trying to think, do you take the integral of that negative 3 also, or is that...
What's sitting outside? Notice as a constant, I pulled it outside.
Right.
So it's negative 3 times the answer to this.
Okay.
That's the negative 3, there's the answer to this. Now the 3 cancels the 3 here. So I end up with x to the 5th over 5 minus x cubed plus 7x plus 6. If you tell me take the integral of negative 3 times the integral of x squared, no. Just like with derivative, the derivative of 3x squared, you don't go the derivative 3 times the derivative x squared. That's the same thing. So that's what the other rules I was playing with, addition, subtraction. When you see them, you just add 1 to the power. What happens if the power is actually a negative 1? Then we get a problem. You're dividing by 0. And you can't. So then what do? Well, let me ask you a question. Let's see if you remember that. What is the derivative of the natural log of x? 1 over what? 1 over x. Or you can write that what? X to the minus 1. So what is the integral of x to the minus 1? We told you can't use this rule. You can't just add 1 to the power and divide by the new power when n is negative 1. Because you'll be dividing by 0. So what's the answer? Who has a derivative equal x to the minus 1 or 1 over x? It's the natural log. So when n is a negative 1, the answer is the natural log of x. Let's see if you remember this. What's the integral of cosine x? What trig function has a derivative equals cosine? Sine of x. What's the integral of sine of x? Negative cosine x. What's the integral of secant squared x? How about positive? Tangent x, the derivative of tangent is secant squared. What's the integral of cosecant squared? What function has a cosecant squared for a derivative?
Cotangent.
Well, the cotangent has negative cosecant, but there's no minus here, so it has to be negative cotangent x. Remember I said to you, if you memorize these derivatives, when you get to calc, it makes your life easy. What's the integral of secant tangent? Secant tangent.
Oh, secant.
That's secant x. Can I review them for the final exam? What's the integral of cosecant x, cotangent x? Negative cosecant of x. Few examples, then we'll go home. and we'll try to wrap it up next class, finish it. We have, like, I'll add 2 more sections on next Monday, because we have a test on Wednesday. But let me add color examples here to play with them. What is the integral of 1 over x squared dx? No quotient rule here. Well, if you look at that, can you rewrite that problem? That's x to what power? As long as the power is not -1, we can always what? Add 1 to the power and divide by the new power. So add 1 to the power, what are you going to have? X -1 over -1 plus c. And what's x to the -1? Isn't that 1 over x? I like the minus on the top. And that's my answer. What is the integral of the square root of x dx? Integral. This is x to what power? 1/2 dx. Add 1 to the power, divide by the new power. Add 1 to the power becomes what? 3/2. You're dividing by 3/2. Don't forget the c. When you divide by 3/2, the same as multiplication by 2/3. The integral of 2 times sine of x dx. I'm trying to mix the rules here. What can we do? Can we pull the 2 outside? What trig function has a sine of x as a derivative? Negative cosine times the 2, -2 cosine of x again, always add that c. How about this one?
3 natural log.
Very good. You can take the 3 outside. This is 1 over x dx. Or 3x to the -1 dx. You can't add 1 to the power because you'll be dividing by 0. So that's the special case. The answer to that is what? Who has a derivative 1 over x? Natural log. What about if I gave you this one? Just dx. X, keep going, because there's a 1 here.
Plus c.
Yep, it's 1x plus c, which is x plus c. What about this one? Well, you can write that square root of x in the bottom as x to what power? 1/2. When you bring it to the top, that becomes what? Negative 1/2. Can we distribute that one? X, what's negative 1/2 times x? X to the negative 1/2 times x to the 1. When you multiply, you add your exponent. So that'd be what? 1/2. Notice the power is different than negative 1. So you add 1 to the power and you divide by the new power. Add 1 to the power. You have, bless you, x to what power when you add 1 to the 1/2? Over 3/2. Add 1 to the power. What's negative 1/2 plus 1? 1/2. Again, if you don't like the 3/2, make that 2/3 x to the 3/2 plus 2 x to the 1/2 plus c. Trying to trick you here. Next one. Maybe my last one. Derivative of sine of x over cosine squared x dx. It has to be something we know from the derivative. Nope. Let me play with this a little bit. Tell me, isn't this the same as 1 over cosine of x times sine of x over cosine of x? Isn't that what sine x over cosine squared equals to that? What's 1 over cosine? 1 over cosine? Secant x. What's sine of x over cosine? Tangent x. Now I bet you know the answer. Who has a derivative equals secant tangent? There's a tangent secant squared. Someone says tangent, but the derivative of tangent is secant squared. Secant. Derivative secant is secant tangent. So I just played with the algebra, so to match one of the format that we know the answer to. I did e to the x earlier. So I'll stop here, and next time I'll add some more. Show you some of the application. Before you leave,